last lesson dealing with systems of equations. And we are going to talk about nonlinear systems. So first of all, what does it mean to be nonlinear? So first, let's look at linear systems and what those look like. So remember, this is a 2 by 2 linear system. Linear systems had multiple variables where the variables had coefficients and they were added and subtracted. Nonlinear systems are going to look very similar, but what is the difference here? Well, these guys have exponents, right? So a nonlinear system might have exponents that are higher than 1, right? These guys just have coefficients. They're being added and subtracted to each other. These guys have at least one term that has some sort of exponent on one of the variables. We will not see any exponents higher than 2. So if you're looking for a nonlinear system of equations, something in there is going to be squared. The good news is that the stuff is very similar to nonlinear systems, and we can use our same two methods. So if you'll recall, we had our first method, which was substitution. Let's say we have something like this. All right, our first step was substitution. What did we do every time? Well, we picked something to solve for, right? And then we substitute. What is going to be our easiest variable to solve for? Usually it's the one that already has a coefficient that's close to 1, right? Which lands us with this negative y. That's going to be the easiest one here. So 3x minus y equals 10. Let's bring the y over maybe to this right side. And then we can bring the 10 over to the other side. So we end up with y equals 3x minus 10. Great. Now with substitution before, what did we do at this point? We would take this expression and plug it back into the other equation. So let's go ahead and do that. So we substitute. So x squared plus, instead of y, we want 3x minus 10 squared equals 100. Definitely always remember these parentheses, right? If we didn't have the parentheses, we would have something very different. We have to FOIL here to simplify. So x squared plus, we get 9x squared minus 30x plus 100 equals 100. Oh no, I'm running out of space. All right. We combine like terms. We've got x squared plus 9x squared, so 10x squared minus 30x. If we combine these guys, if we bring this over, right, we have 100 minus 100, so 0. I messed up here. We have one 30x, right, and then we also have a second 30x, so this actually should be minus 30x as well. So we combine these two, we get, I was totally wrong here, 60 minus 60x. All right, what do these two terms have in common? Well, we can pull out definitely an x and also a 10, right? If I pull out 10x, what's left over here? Well, just x. What's left over here? Minus 6. Again, I can set each of these factors equal to 0. I get x equals 0 and x equals 6. So unlike last time where we only got one answer, right, for any given variable, we have two. So this time, when we plug back into what we started with, we need to plug both of these two answers in. Let's plug these back into our original equation. So there's a little bit more nuance to this than there was last time, right? Before we could plug it into either and it would be the same thing. Now, if I plug them into this equation, right, any x value I plug in here is going to give me one y value only. If I plug in an x value to this equation, because this y is squared, it might either give me no solution, right, if it ends up being equal to a negative, or just one solution if it's equal to 0, or two solutions if it's any positive number. So there's a little bit of nuance to this one. But if we plug it into this one, this linear equation, we get one answer and it will be the correct answer. So I'm going to plug it into this one. I could totally plug it into this one as well. I would just need to check both answers to figure out which one was the right one. So let's plug it in here. If I plug in x equals 0, I have 3 times 0 minus y equals 10. Which, again, oops, I forgot, right? We already solved this for y. So we don't need to plug it back in and do any more solving. We can just plug it straight in here. So 3 times 0 minus 10. So y is negative 10 here, giving us a solution of 0, negative 10. And if x is 6, I can do the same thing, plug it straight into this guy. I get 3 times 6 minus 10, which gives me 18 minus 10, which is 8. So we get a second solution of 6, 8. And these are my two solutions. Again, if I'd plugged it into this equation that has x squared and y squared, so let's say I plugged in 0, I would have 0 for x, so 0 squared, plus y squared, so just y squared on this side is all that's left over. I'd have y squared equals 100. And what that would give me is y would be equal to positive or negative 10, right? Whenever we take the square root of something, it's positive or negative. The problem with that is that only negative 10 is going to also fit with this equation. So the solution 0, 10 would make this equation correct, but it would not make this second equation correct, so it is not a valid solution for this whole system. If I plug into this one, it's going to give me the correct number that works for both. I may get an extra if I plug into this one. So these are my answers. I could plug in here. I would just need to check. All right, let's do another. Let's say I've got x squared minus y equals 1 and 2x squared plus 3y equals 17. Well, what does it make the most sense to solve for? Again, it makes the most sense for us to solve for y here. So let's do that. X squared minus y equals 1. We can bring y over. So we have x squared equals y plus 1. We can bring this 1 over here. So y is x squared minus 1. I want to substitute. So I take this up here. I need to plug it into the other equation. We want to make sure we always do that. I made that mistake here. So we have 2x squared plus 3 times x squared minus 1. Again, we want those parentheses around. I simplify. I have 2x squared plus 3x squared minus 3 equals 17. I combine these guys. I get 5x squared. I bring this guy over to the other side. I know normally we want to bring it to the left so that it's all on one side, but in this situation, you'll see what happens. If I bring this over, I get 20. So now I can isolate x further by dividing by 5, both sides. I get x squared equals 4. So x is what? Square root of 4, which is positive and negative 2. Don't forget that positive and negative. Okay, so we need to plug both of these in. So let's say x is 2 first. Where should I plug in? Well, doesn't matter because both of these equations, we don't have a y squared, so we don't have the possibility of having some plus or minus that doesn't work. So we can plug it into either. I have this done for me, right? Y equals x squared minus 1. So since I know y equals x squared minus 1, I can just take 2 squared minus 1, so 4 minus 1, or 3. So I have the solution 2, 3. When I plug in x equals negative 2, I have y equals negative 2 squared minus 1, which again is 4 minus 1, which is also 3. So I have the solution negative 2, 3 as well. And that's the answer. Again, we're following the same steps as before. Method 2, you'll remember from solving linear systems, is elimination. So just a little bit here. Elimination follows the same steps as elimination for linear systems, as long as we have like terms. That's very important. As long as we have like terms. And then just before we start, try to eliminate the higher degree variable if possible. So let's give this a shot. Let's say we've got 3x squared plus 2y equals 26, and 5x squared plus 7y equals 3. We've got one of those kind of annoying situations where we don't really have a very clear, nice thing that we can multiply one by to get the other. So we have to multiply both equations here by something. So what's the least common multiple of these two numbers here? The smallest number that can be divided by both 3 and 5 is 15. So let's multiply this top one by 5 and this bottom one by, remember we need opposite signs, so let's do negative 3 here. So top one we get 15x squared plus 10y equals 130. And negative 15x squared minus 21y equals negative 9. We add these guys together, we end up with 0, negative 11y, and 121. 121 divided by negative 11 gives me negative 11. Okay, now that we've got this negative 11, we've got to plug it back in to get x. Again, doesn't matter which one we choose here because they have the same degree. So I'm going to use maybe the first one, just because. So 3x squared plus 2, we plug in negative 11 instead of y. So we have 3x squared minus 22 equals 26. We bring that 22 over. We've got 48 here. 48 divided by 3 gives me 16. And then, of course, if x squared is 16, x is both positive and negative 4. This means I have two solutions, 4, negative 11, and negative 4, negative 11. Sweet. Example. Let's say we've got x squared minus y equals 4, and x squared plus y squared equals 16. First thing is we need to decide which variable to eliminate. So we need to figure out which one we can have like terms that have equal coefficients with opposite signs. Which one are we going to do that here with? We have to do that with x squared here. The reason is because y squared and y are not like terms, right? We can't eliminate y because they're not like terms. There's no coefficient that I could give to y that would make it a like term with y squared, right? There's no real number coefficient that I could multiply by y to make it a like term with y squared. So we can't eliminate y here. We have to do x. So they both have coefficients of 1, which means that 1 needs to be negative. I'm just going to make this top one negative. So we have negative x squared plus y equals negative 4. We're adding that to x squared plus y squared equals 16. We add these together, of course these cancel. We have y squared plus y equals, right? It's not one term this time, because again, they're not like terms, so we have to keep them separate. And then we get 12 over here. We subtract over, equals 0. We have to factor what adds up to 1 and multiplies to negative 12. Positive 4 and negative 3. So we end up with y equals negative 4 and y equals 3. We have to plug both of these in to figure out what x is going to be. All right, well, let's plug them in. Doesn't really matter which one we plug into here because even though these guys have different degrees, the x has the same degree. That's all that matters. We need to look at what we're looking for and use the one that has the smaller degree. But here they have the same degree, so we're good to use either one. So when y is negative 4, I'm going to use the first one because it's simpler. We have x squared minus negative 4 equals 4, right? I'm replacing y with negative 4. So x squared plus 4 equals 4, which gives me x squared equals 0, which means that x is 0, which gives us a solution of what? 0, -4. If I plug in y equals 3, we have x squared minus 3 equals 4. We bring that minus 3 over. We get x squared equals 7. Interesting. We take the square root, and we get plus or minus the square root of 7. So this time we have two solutions, one being positive square root of 7, 3, and negative square root of 7, 3. So this system has 3 solutions. Looking at number 1, this guy looks like we don't have anything that has the same degree, right? We don't have like terms for x or y, so we can't multiply by anything to do elimination, so we have to use substitution here. The good news is that that'll be pretty easy, right? Solving for y is going to be very simple. We just add x over. So we get y equals x plus 4. We can plug that into our other equation. We get x squared plus y, which is x plus 4, squared equals 8. I combine like terms, or I distribute. So x squared, I have to FOIL here, so I get x squared plus 8x plus 16 equals 8. I combine like terms, I get 2x squared, 8x on its own. 16, this 8 comes over, so we have plus 8 equals 0. We need to factor, so let's start by pulling out what each of these have in common. Looks like the only thing they have in common is 2, so I'm going to pull 2 out. I'm left with x squared plus 4x plus 4. Is this factorable? Is there anything that multiplies up to 4 and adds up to 4? Totally, right? X plus 2 and x plus 2. So I have the solution x equals -2. I plug that in. Which one should I plug it into? If I plug it into this top equation, I have y squared, right? That's going to give me something funky, right? It might give me 2 answers. So I need to plug this into the smaller degree one, right? Because the y here has a degree of 1. Again, I could plug it into this one. I would just need to check both answers to figure out which one was the right one. So to do less work, I'm going to plug it into this bottom one, which I see, remember, I have this rewritten so that it's going to easily give me what y is. So I know that y is x, so -2, plus 4, so 2. So I have the solution -2, 2. Great, easy. All right, let's look at this guy, number 2 here. This guy wouldn't really be easy to solve for one of these terms, right? Solve for x or anything like that. So I think it might be easiest for us to use elimination in this case. So elimination, I need a equal coefficient with opposite sign. Would be pretty easy to get these guys to be equal but opposite signs, right? I'd have to multiply this by -3. But this guy already has opposite signs, so I'm actually just going to multiply this equation by what? 4, right? So I've got x squared. I'm going to draw sort of a line here to keep us separated. Okay, so x squared plus 4y squared equals 8. And then 12x squared minus 4y squared equals 44. I add these together, I get 13x squared equals, right? Nothing here. 52. I divide 52 by 13. If you play cards, you might know that this is 4. And then x is plus or minus 2. Let's plug both of those in. Doesn't matter which one we do it to because all of these terms are squared. So I'm going to plug in positive 2 first. I'll do it to that first one so we don't have to deal with the 11. So 2 squared plus 4y squared equals 8. I've got 4 plus 4y squared equals 8. So 4y squared equals 4. Y squared equals 1. So y equals positive and negative 1. When x is negative 2, I get pretty much the same thing, right? I get positive 4 here, plus 4y squared equals 8. This is the same thing as this, so I work all of the work down and I end up getting the same thing, y equals positive and negative 1. So I have many solutions here. I have the solution 2, positive 1, 2, negative 1, right? That's from this part. And I also have the solutions negative 2, positive 1, right here, and negative 2, negative 1. So 1, 2, 3, 4. All right, that's all I have for systems of nonlinear equations. Thanks, y'all.